have everything going right now. So you can, everyone see the opening slide there?
Yeah, we can. Absolutely fine, John.
Okay, great. Well, again, thank you for allowing me to speak. Yes, I was here, roughly, it was last year sometime, talking about the DC polarity checker. And believe it or not, there's about 300 of those running around the planet somewhere. It seemed to be a very popular little tool, and it has saved me quite a few headaches. So that was a lot of fun. But today I want to talk about a different project and a different article. But first, I'll introduce myself for those of you who you weren't here last time. My name is John Burnley, NU0V. I have a extra class license here in the States. I was first licensed back in 1970 and have gone through a lot of the different aspects of amateur radio, from operating to contesting. I still love DXing, but like a lot of other people, I kind of fell out of it for a while. And then back in the 90s, got a little more rejuvenated. I'll talk about that in just a second. But about me personally, I've been married to a lovely bride for well over 40 years. She and I love to travel. We love to go bicycling. I'm originally from Kentucky. So Kentucky basketball, also one of my passions, but amateur radio has always been a passion with me. And one of the biggest highlights that I had a couple of years ago, just prior to the pandemic, was that I got to operate W1AW. And that was a very interesting experience, because it was like being Rare DX. I never had so many people want to contact me ever in my life. So that was quite enjoyable. I currently have transitioned from industry about 8 to 10 years ago, from IT, and I now teach. And I teach at Des Moines University in their grad program on a part-time basis, and I am a full-time professor of practice at Iowa State University here in the state of Iowa. And as I mentioned, in the 90s, my amateur radio enthusiasm was rejuvenated, and it was because of QRP, low power operating. I found something that was challenging. I found something that I thought was exciting, and it actually introduced me to something I really hadn't done a lot of before, and that was building. And yeah, anything I had done before was pretty much on the operating side. So I started building and really enjoyed doing that. But everything I ever built was someone else's design, and it was kitted. I had never done any of my own board work or any of my design work. And then in 2018, at the Cedar Valley Hamfest, which is near Iowa City, Iowa, Barry Bulow, Whiskey Zero Italy Yankee, did a presentation on KiCad. KiCad or KiCad, I've heard it pronounced different ways, but it's a software where we can do board design. And Barry's talk was very inspirational, and it got me thinking about, I could do that myself. And this whole experience that I've had, not only with the checker, but with the switch, has been something of a journey of discovery and learning. I'm not an engineer by trade, and just like a lot of ordinary folks who get into ham radio, we learn each and every day that we do things. So Barry's talk got me on the path then to doing some of my own design and fabrication work. Well, like all things, this project, this web-enabled antenna switch, started out with a need. I had a QRP Guys vertical that, if any of you are familiar with that antenna, it has manual switches where you would go out and manually switch to facilitate band switching. So I thought, well, why couldn't you put together a remote switch and install that at the feed point to accomplish that? And so I thought about it and put it on the back burner. And like everything else that happens in my life, I got distracted and forgot about it until I noticed an article in QST. I don't know how your shack is, but I have a pretty large stack of unread magazines, and I do get through them, but I'm not very timely. But in the September 2016 issue, Kilo Echo 2 Zulu Tango had an article about a web-controlled receiver antenna switch. And so it clicked. That might be the basis of the design that I would need in order to do the work that I'd wanted to do on that antenna switch. It was a pretty interesting article, and the original features of his switch, it was receive only. He had a static IP address on that. His coding, he used nested if logic, and we'll talk about that in just a few minutes. In order to use his interface, and his interface, the switch is running, essentially, it's running a web server, and then you access it from a browser. And in order to access it in his version, you had to do a hard code the URL, and a little cumbersome in typing all of that out. It was designed for a single radio for multiple receiving antennas. He used low signal relays, and the whole project was based on a breakout board from Adafruit it's called their Huzzah board. It features an ESP8266 processor. What's really nice about that processor is that it comes with Wi-Fi standard, so you can access it through Wi-Fi and not worry about a hard Ethernet connection. So that's where we started, and I, like any ham out there, I couldn't leave well enough alone. I had to have my own twist on this. So the modifications that I put into the switch, first, instead of having a static IP address, I converted that in order to give it a dynamic IP address assignment using DHCP. DHCP is a dynamic host control program, and what it does is that it will serve to a device on a network its IP address, subnet mask, DNS server IP address, and then the default gateway. Those are four things that any device would need to access a network. Now, what the benefit for me on that was that by being able to dynamically get my IP address, then I could actually take the switch and run it in other locations instead of going in and then having to recompile a static IP address. So it allowed me just a little flexibility. I went with a switch statement logic. The original design used a nested if, and a nested if is a coding style where you would have an if statement, if this, and if it's true, it would execute something, else it would do something else. And so a nested if is if, else if, else if, else if. Works fine. For me, a little harder on the support end, especially if you're trying to figure something out. A switch statement, and I'll show you an example of that a little bit later, is for me, a little more intuitive. There's nothing wrong with what the original designer did whatsoever. It worked. But this was just something that worked better for me. One of, I think, the major improvements to that design is that on the web page, I gave it radio buttons, and yes, the irony doesn't escape me, but radio buttons made it more of a graphical user interface where you would point and click to the radio or the antenna that you would want. I gave the option of multiple radios. You could have 3, you could have multiple antennas, up to 3 antennas. And if you wanted to change that, then you would have to go in and then modify the code. And some of the feedback that I received, a lot of people out there really intrigued by the idea, but they really didn't want to get into any code and make changes. They just weren't comfortable with that. Another little customization item was that you could supply your own names for the antennas in the radio. You do that at just prior to compiling it, and so then you would know which radio was connected to which port. I did add LCD support, which would then tell you what radio and what antenna was active. For the switch, the original was receiving only, and then the goal of this one was to allow RF transmission. And finally, the last thing that I added to it was a reset switch. These little microprocessors, occasionally they can misbehave. And so the reset switch, just a real easy way to reboot the device. As far as the hardware goes, it's pretty simple. This was the original KiCad schematic that I sent to the league. Their version's a lot prettier, and so we'll kind of stick with their version. But it's a pretty simple circuit. The web server receives a command. Based off of that command, then it will either enable a port, it'll set it high, or it will set it low. If it sets it high, then it would turn on an FET, which would then energize a relay and then switch in a port in circuit. So it's a very common practice of using relays. And so there wasn't really, I think, any big surprises for this circuit, but it really worked pretty well. Now, we'll take, I guess, a quick look at the LCD functionality. And some of these pictures that I have, the first thing that I did was get the software to work and get the LCD working. And this is just a picture of my little impromptu lab for programming that Huzzah board and getting the LCD to work. But the LCD uses I2C communications to communicate with the LCD. For those of you who are a little more into the tech, it stands for Integrated Circuit. Essentially, it's a serial type protocol that allows multiple peripheral devices to communicate with that controller or the Arduino. And it ties up two signals. One is a clock, and then there's one for the data itself. And it's more of a bus protocol. Okay, so my first goal was to replicate the design. So I replicated what KE2ZT did. Exact same relays, fabricated a board, which this was actually the first board that I had ever fabricated. So I was pretty excited about that and quite pleased with it. And really, these days, we have so many low-cost fabrication houses. I wish I had done this a lot sooner. But during this time, I was learning KiCad. So I would make mistakes, and that led to different versions of the board, and you'll see some of those versions. Now, one of the things about this initial version that I didn't really realize, again, one of the learning moments, was that the signal traces were not adequate enough to allow transmission. And so that was the driver then to go to some of the later versions, was that I wanted to be able to transmit. But I had a little problem that I hadn't planned on. And in the engineering notes for the ESP8266 processor, they specifically tell you not to have a specific GPIO pin low during boot. Based off the documentation, I thought that when I set that a low, that it would be okay. What I learned was that the engineers were pretty serious about that. And yes, if it is set to low during boot, that the ESP8266 will loop. And I was incorrect in my assumption of when my programming took control. So I had to fix that with just a little cut a trace and then jumper it to a different pin. And then everything worked fine. The next iteration, I took care of some of the trace issues. This one I was able to transmit on with QRP power levels. I operate QRP pretty much all the time, and so I was happy. I had accomplished the goal, and everything was working quite well. But something came to my attention, and I thought, well, what if we did something just a little bit different? Now, I never really measured the performance of this version as far as some of the specs. You will see some performance information on the later version, the version that made it into the QST article. On one of the QRP email lists, and whether you operate QRP or whatever aspect of the hobby that you deal with, you're probably on some mailing lists, and whichever one I was on, and I don't remember if it was QRP or a different one, someone had mentioned about an analysis that had been done on relays, because the conversation was talking about using relays as something that could handle RF switching. And Whiskey 6 Papa Quebec Lima did a really nice analysis on using inexpensive relays in the types of project like this web switch project. So I went through it and I found a relay that performed pretty well. In fact, I used the single pole double throw instead of the single pole single throw, because the performance actually was a lot better on the double throw. The relay, though, it was good through about 6 meters. Anything above 6 meters, you would need some type of compensating capacitance to make it better to work with. However, if you did that, then it degraded the performance at some of the HF levels. So that's something that is not incorporated into the design that I have. So if you were to build this type of project, you would have to compensate then if you wanted to operate frequencies 2 meters and above. But I would suggest any of you who have an interest in this, go out and take a look at his website. He has a lot of good information about a variety of projects, but I thought this one was particularly interesting. Now, the version that was actually in the article, version 4.2, it started at 1, I was up to 4. I don't think I even fabricated version 2. I went right to 3 because of a mistake that I had found. My efforts in this design were probably a little more expensive than it should have been, because I would make changes and I'd fabricate a board and then play around with it, learn from it, and then go on and do something else. But in this version, and the version again that was in QST, it uses the relays that were listed on that site. It's an Omron, and for the life of me, I can't think of it. I can get that for you if anybody's interested, or it should be in the article itself. We're going to call a senior moment on that and then play the age card. But as I mentioned, I have multiple versions of this project out there that I've played around with. One that I haven't completely finished playing around with. I haven't built it yet, but complete RF path isolation, and was looking at something. I was wondering how well would this work, perhaps in a balanced line environment, and that's the reason that I put that together. But I haven't played with it yet, so I really don't have a good answer for you. The application software, the hardware, I think everyone pretty comfortable with. There isn't anything outrageous that was done. Pretty common techniques there for the hardware portion of the switch. This software, though, is an interesting piece of it because it's the brains of the whole operation, so to speak. One of the goals that I had for this was platform independence. And what I mean by that, since we are using a browser, anything that runs a browser should be able to run the switch. I have tested it successfully on my smartphone, and you can see that on the right. Yes, I am a Verizon customer. From a desktop, the desktop is in the middle. I have run it on a tablet. I don't have a smartwatch, so I'm making a untested claim on that one, but it should work. But I have not tested that. But I have tested it on my Amazon Fire Stick, and the lower left-hand picture is actually, it's running on my TV in the family room on an Amazon Fire Stick, and that was taken just prior to Christmas. If it runs a browser, it should work in order to control the web switch. The application itself, pretty simple design. This is the flow chart for it. When you start off, the first thing that you would do is initialize the variables. Then once that's done, you connect to the network. And in our case, we're using DHCP. We're asking the DHCP server to give us the IP address, subnet mask, DNS, and gateway addresses so that we can successfully get on the network. Once that's finished, we start the server, the web server that runs, because the programming on that Arduino is actually running a web server. So we start the web server, and then it starts just listening for a client connection. And it will listen. If there's no client, it just keeps looping until it gets that client connection. Once it gets the connection, then it will read the command sent to it from the browser. It'll do a validation on the command. If the command is invalid, then we set an error condition. And the error condition that I had set by default, which has come back to haunt me with some of the feedback, was that it would automatically ground the radios and the antennas, because I was worried about it not understanding something and then possibly connecting two rigs together or something like that, which should not happen, but that was the logic behind when I did that. It would write a message to the LCD essentially saying, hey, I grounded everything. And then it would close the client connection and go back and listen. If the command was valid, it would switch to the requested port for either the radio or the antenna, whichever one had been requested. It would send a response and the web page back to the browser, and then it would close the client connection, go back to listening, and spin. I mentioned earlier about the nested if versus the switch programming statements. On the left is the original code that the author had used. And as you can tell, if it's this, do this. If it's not this, do this. If it's not this. The switch statement for me was just a little more reasonable. And in this case, it tests in antenna number. If it's number 1, it does this. If it's number 2, it does this. If it's number 3, it does this, and etc. It's just personal preference. There's nothing wrong with what KE2ZT did. What he did was perfectly fine. If you've ever done some programming, there are a million different ways to accomplish the same thing. Now, it just really boils down to personal preference and what you're comfortable in doing. But I thought for me, one of the bigger things was making this interface point and click, because prior you had to key in the IP address, the port, / and then you go into a directory, the type of syntax, and you had to hard code all of that. With the version that I put together, it's simply point and click. And so you just click on the radio that you would want, or you click on the antenna that you would want. If for some reason you would like them all grounded, you would click on that. So point and click. And the HTML code, in order to get that to work, is really quite simple. This is for the antenna section. As you can see, those 4 statements, that's all there was to it. In order to get something, that radio button checked, you tell it checked. And if you can see in the example, unfortunately the graphic doesn't match the coding there, but on the last one, which is grounded condition, all disconnected, you can see the word checked. And that literally is how you tell the browser to display that as checked. From a performance perspective, very good friend of mine, Jerry Hall, Whiskey Zero, Papa Whiskey Echo, helped me in doing some of these measurements. And these were taken using his NU0V. So you can see those three parameters that might be of interest, SWR. And as you can see, the higher that we go in frequency, the worse that it gets. Return loss, the higher in frequency, the worse that it got. And the isolation, and by isolation, what I mean is that is the measured signal on a port that is not connected in circuit. So these are the ports that are switched out. So if you have multiple radios, that's the reason that we did that measurement, because we wanted to make sure that that isolation or that signal was far down enough that it wouldn't present a problem to any other rig that might be hanging off the switch. Now, I've only tested the web switch at 100 watts based off of the circuit trace size and the capacity of the relays. It theoretically could run at much higher power. However, I have not tested it on that, but it has been tested at 100 watts. Here are some of the, and this was using one of the utilities with that NU0V. I think this was NU0V saver. Some of the plots that were generated that illustrates the return loss getting worse as we're going higher in frequency. The insertion loss actually is pretty good through 6 meters, and then it starts to degrade once we get to 2 meters and higher. The impedance on the left, the SWR on the right. And again, these graphs actually reinforce the analysis that Whiskey 6 PQL did on the relays. So we were able to, I don't know about matching the numbers. I never compared it number to number, but the trend certainly supported the information that he discovered when he tested those relays. As far as isolation, these are the numbers or the plot that we see for isolation. I arbitrarily set minus 60 dB as the floor is what I would claim for what the switch, the isolation for the entire switch was. Although in the HF region, 30 megahertz and below, I think based on the measurements that we had, it's much better. But I'd rather be a little conservative on the claims that I make and then be aggressive in those. But one of the most common questions that I would receive after the article came out was, is this safe for my rig? If I hook multiple radios to the switch, will it be safe for my rig? And the answer is, well, it depends, and it depends on a couple of things. Just as a slight refresher, we use decibels as a common unit of measure in a lot of things that we do in our illustrious hobby. The decibel or dB, it's a relative measurement of an output to an input. Just dB itself is a dimensionless type of measurement. We have other variations of decibels, dBu, which is expressed towards voltage, but it's instead of being dimensionless, it is dimensioned because it is referenced to a specific voltage. dB lowercase u is referenced to a 0.775 voltage. dB capital V is also a voltage expression, but it is dimensioned then or measured against a defined value of 1 volt. dBm is another common one. This is really based off of power. It is an absolute measurement of an output to a defined reference value of 1 milliwatt or 1/1000th of a watt. Well, what does that really mean? We use dBm quite a bit, and to put things in perspective, 50 dBm from a power perspective would be the typical transceiver output of 100 watts, 37 dBm, 5 watts, and that's typical of our QRP transmissions. The IEEE, I left out an E in that, didn't I? 802.11 variants, that's Wi-Fi. So a lot of our Wi-Fi devices that are out there are running at minus 10 dBm or 100 microwatts. S9 signal would be minus 73 dBm, and then plus or minus 6 dB for each S unit. And then to put that on a scale so it's a little more readable, that kind of gives you an idea of what we're working with. 100 watts at the plus 50, and what we're used to receiving really down lower on the scale. This is just another bit of information that gives you some specific levels as far as S units and then dBm. And I found a couple, but really what I want to get to is that I was having trouble figuring out what is something that I could, tell people that, yeah, it's safe. Well, in the case of running 100 watts, I arbitrarily set my claim is that it was 60 dB lower. So at 100 watts, it's 50. So what I was saying is that the minus 10 dBm level is, where you might expect leakage on an unused port for another rig that might be attached to it. Now the big question is, well, is that okay? And I started looking and checking sources, and I looked and I looked and I looked, and to be honest, I didn't really find anything. What I was looking for was a good rule of thumb that at some specific level, then you could consider that safe as a signal being injected into the antenna input jack on a transceiver. So I was getting a little frustrated, and I kept looking until finally I found some information, a presentation that Bill Leonard, N0 Charlie Uniform, had put together. And in here, he referenced some information saying that the maximum signal that you want to inject is about 10 dBm. And he also claimed that the commonly used guideline was plus 10 dBm. But I really couldn't find anything really to back that up, because I didn't want to tell people that yeah, it's safe for your specific rig unless I had just a little bit more information. And so I searched some more, and I found some of the information that Leonard had found, one from Array Solutions. I found another reference at activeantenna.eu that referenced that 10 dBm threshold. So at 10 dBm, that's roughly here, which is still below, or it's above, what I felt was a safe level based on that isolation figure. So, what it means is that that power level of minus 60 dB from the 100 watts, would potentially be safe. But I really wanted to be sure, because I wanted to make sure that, my green line, was valid. And what I ended up doing, just to kind of try and help figure some things out, I started looking at service manuals. And this is the example of the service manual for an ICOM 706. And I found in the service manual that the maximum threshold was 20 dBm. And so that told me, okay, at least for the IC 706, we're probably in good shape. And again, it's dBm, which is that unit of power at plus 20, that's at 0.1 watt or 100 milliwatts. And we certainly would be fine for that rig. And so I kept searching and looking some more. This is for the ICOM 7610, a more recent rig. And again, for ICOM, it was at that plus 20 dBm, or the 100 milliwatts. So again, we were in in pretty good shape. For the IC 7300, again, 20 dBm. So it looked like ICOM had really standardized on that as their maximum RF input to their series of radio. Unfortunately, that's not universal across all of the manufacturers. So I went to take a look at Kenwood. I actually couldn't find any Kenwood service manuals that I could reference, but I did find some for Yaesu. And for Yaesu, I found for the FTDX 101 MP. And in this case, they're saying that, and this was not specifically mentioned as the warning, this is the max, this is in their alignment procedures. And so what I was looking for is what was the maximum that they would recommend, or what they were telling you to do during that alignment process. And in this case, for the FTDX 101, it was plus 10 dBu. Well, dBu is different from dBm. This is set off of that voltage reference of 0.775. So then I had to go and convert, and I found a really nice utility on for analog devices on analog.com. They have a utility that will do all these conversions for you. And so I converted 10 dBu, and it ended up that it was magically just a little bit above 20 dBm, which is that same threshold then that we were seeing for ICOM. So I felt pretty comfortable with that. Again, we're at 100 watt level. We're running around where the green line is at minus 10 dB, and their maximum was then plus 20. So we're actually in pretty good shape. The FT991 had some references. Those numbers looked a little bit high, so I didn't necessarily trust those. But the point of me telling you this is that, go to the manufacturer. They should be able to tell you, what is safe for your specific rig. If you have access to the technical documents, you might find something there, but check with the manufacturer. But I feel pretty comfortable with what I've found so far, that we're in pretty good shape. Now, when the switch was originally put together, and this is actually referenced in the article that Nick is going to send out to you, I had a problem, and I think that KE2ZT also mentioned something like this in the article. I'd actually have to go back and look, but I believe that he complained that every now and then the switch would do something funny, something unexpected. And I also noticed that there was a intermittent error. This is after I first just put that together, that doing nothing on the browser. So I had not initiated a transaction whatsoever. We hit an error condition of where it went all grounded. And so I thought, okay, that's not good, as you might expect. And I went and verified, yes, indeed, all the connections were grounded. So the Arduino had detected something that it felt was an error. Now, one of the things that I've worked with, not only in teaching, I teach networking at Iowa State University, but when I was in industry, I was in IT well over 30 years, back in my technical days, which admittedly were quite a few years ago, but I did work on networks. And so we had to use tools in order to figure out what's going on. Much like when we're working with circuits, we have tools like oscilloscopes, digital voltage, volt ohm meters, something that will give us an indication of what's going on within a circuit, or in this case, using a network sniffer, what's going on in the network. Wireshark is a common network sniffer, and a network sniffer is a tool that whenever a packet comes to your device, it just makes a copy of it. If you ever monitor network traffic, there's a lot of traffic that goes on that will hit your device, but it's not intended for it. In fact, you would be actually pretty surprised how much traffic that there is on a network. But these types of tools will capture that and then give us an idea of what's going on. So in this case, I Fired up Wireshark. I started sniffing the network, and since this is a Wi-Fi device, by default, Wi-Fi communications are a shared type of media, so you see a lot of traffic that's not destined for you. But when I captured the data, and what you're seeing now is the output from Wireshark, and I filtered the display. I've narrowed down what's actually shown, because otherwise there would have been literally thousands of packets. You can generate thousands of packets in around a minute based off of that capture. There's a lot that goes on that network. But as you can see here, the get command, the HTTP 1.1.1, that's a valid command that is expected by the switch. The get with the antenna in it was a command at the time. The format of the command now has changed since the original article was written. But it points to a command that I had not anticipated. So that's the culprit. That command went to the web server, and it just, I don't know what that is. And so that it set the error condition. Many of you probably know what a favicon .ico file is. A favicon is a small graphic that sometimes will be displayed on that web page in the browser. The arrow is pointing to the one for the ARRL in this case. And it's something that the browser will do on a random basis. And until you tell the browser no, it will still occasionally ask for that favicon. So that's what the problem was. So I had to go back and then change the code to make sure that it would account for that. The proper response to that favicon request is a return code of 404. I don't know if you can see my cursor there, but 404 means file not found, and that will silence the browser. It won't ask for that again. Now, one of the, I don't want to say challenges, but one of the nuances of this project has to do with currency and syncing. I'd mentioned before that the one thing that had come back to really haunt me was this issue of where if I detect an error, then I would ground it. One of the things too is that if you would open up another browser and go to the web switch, it would treat it as we were starting from scratch. It would automatically go to the all grounded condition. That feedback came back pretty negative from a lot of people on that. The reason I had originally done that was because I knew that there would be syncing issues exactly for this problem. If that someone opened up a browser to the switch, made a change, it would not be reflected on the other browser. So that's an issue, and that in order to fix that, there are something that I could do to fix it. We could force the browser to refresh every 5 seconds during some time interval, but there's a problem with that. The ESP 8266, it's TCP implementation. I mean, these are just really small devices, and so it's not really robust. There is a problem with their TCP implementation that you can have a client, or you can have a situation where there's no client, the client has been closed, but it acts like, and it still has the settings as if there is a connection. And so in order to do that browser refresh, we would have to allow the condition of trying to deal with that situation of TCP, and unfortunately, it would cause an endless loop, which is something that I had encountered. So that's one of the operational things. But as long as you don't open up an additional browser, then everything was fine. Now that's and what I'm talking about now is the version of the software that was with the article. there are some updates that we'll get to in just a few moments. Nick, how am I doing on time?
You're okay, John. Yeah, fine. Carry on. You're
Okay.
fine.
I'm about halfway through my slides, so we have plenty of time, and that's good. All right. I like this graphic because this is how I felt just prior to the article coming out. We were literally weeks. We've been through all the final review. The ARRL has the source code. I happened just to get on to do something, and guess what? There's somewhat of a problem. This is a Wireshark output as well, and I hope you take something away from this about some of the tools that are out there that you can use. In a perfect world, the exchange with the web switch would look like this. You see those 3 TCP packets prior to the HTTP packet. That is session establishment. In order to exchange data through TCP, it opens up a TCP connection or a TCP session with both parties, and both parties have to have a session defined. And that's what those first 3 packets do. Once the session is defined, then we exchange data. So in this case, we see the HTTP packet where I clicked on either antenna 1 or radio 1, and it's sent to the web switch. The web switch responds with the TCP packets that begin the transmission of the web page that comes back. So the web page actually comes back over several packets. And then at the end, when we get the acknowledgement, we see the final HTTP packet with the return code of 200. And with HTTP, a return code of 200 is all good. Everything's clear, which I thought was crazy. Being an old mainframe programmer, 0 was great, 4 was okay, may want to pay a little attention, 8 was bad, and anything above 16 was catastrophic. So 200 still grates on me, but that's, I guess, my own personal grief to deal with. After we get the acknowledgement that everything's okay, then we go through session termination, and those final packets, the acknowledgement, the ACK by itself is acknowledging the return code or that HTTP packet. And then those final 4 packets is session termination, where each party then will go through that disconnect process. That's the perfect world. Now, what I was seeing was this. And just to kind of walk you through it, we went through, and I don't show it here, but we went through session establishment. We send the initial get HTTP, but then we start seeing a bunch of traffic, and we see a connection reset. In particular, where we see a little bit of the transmission, but we never see session termination. So something was hanging in the browser. And so I was scratching my head a little bit about that. I pulled up my old iPad, an iPad 2, and everything worked fine. Everything was perfect. And okay, so that led me to believe that one of the either Microsoft Patch Tuesdays or some type of update to the browsers then had impacted what we were doing. And so then the search begins. Now, when I'm in a professional environment and we run into problems, normally we'll have quite a bit of documentation that can lead us to a resolution. Anyone who's done any programming on these micro platforms can tell you that really your support is discussion boards and Google. And so began the search of what was going on to see if I could find things. And you can't always find something that's going on with that. You have to excuse me just 1 second. Meet my lovely wife. Say hi to the group. Say hi to the group, Becky.
Sorry.
I'm actually in a pretty tight little area.
Okay. All right. I'm out of here. Sorry.
Yeah, that'll come back to honor. All right, my apologies for that. So anyway, we weren't going through session termination. So I looked and I finally on, I think this might have been the Expressive website, which is the manufacturer of the chip itself, the ESP8266. I found an old thread which talked about the situation that I was seeing. And again, for anyone who's done any type of support for these micro devices, it can be pretty problematic in getting any type of information or support to get these things fixed. But in this discussion, it talked about that the experience that they had had was that the browser was hanging because the web server had not sent the length of the data that it was sending. And so the browser was just waiting. It was waiting on the rest of what it thought was the data. And so I took the recommendation for that and I changed the coding. The one on the left was the original one. We just sent, we printed it through client print. And then we changed the HT or that command then to include the length of actually everything that was sent. And that cured the problem. So that tells me that at some point between when everything was tested and the last time that it was tested to when we discovered the problem, something changed. Something changed on that browser, whether it was Firefox or it was Edge for Microsoft or Chrome. Somebody implemented something that was reliant on knowing what the length is, which makes sense. One of the most common attack vectors that we see on the web has to do with manipulating information like length of what's sent. I don't know if any of you remember the Heartbleed vulnerability was a big thing with SSL several years ago. And the method of attack for that was that it was lying about length of data that was sent, that it could then retrieve information out of memory. But that's a whole different conversation. All right, so what's next? What's next on the web switch? Since the article was published, some things have happened or are going to happen from the hardware perspective, and I haven't done any of this. Static protection, I'm looking at possibly implementing that or giving the builder the possibility of implementing that. I am planning on porting this to an ESP32. In particular, the 32U, which I'm hoping they'll come out with a newer version of that because I think that they have that marked for isolation, or not isolation, but end of life. But as you can see, it has a external antenna port. And that's one of the drawbacks with the Adafruit Huzzah board is that it's an onboard antenna. And so you can't completely shield the switch. It has to have a way to receive the Wi-Fi signal. This would solve that. I'm looking at implementing push button selection on the switch itself. And so that not only could you use the browser to select it, but you could push a switch on the switch itself and do that as well. And then possibly implementing a 4-line LCD. So those are some of the things that are going on. As far as the static protection, Phil Salus, 85X, has a really good article on his website where I got that idea. In this case, he was working with a CAT 500, I believe, and looking at protecting some of the ports on that, where he's using some actually pretty inexpensive GDTs. I think they're on Mouser for about $4, and then some blocking capacitors as well. So it looks like it's something that could be actually implemented pretty easy. The only drawback to that is that you have to identify which ports are going to be used for radios. And so it makes some of the exciting things I'm going to talk about in a minute a little less flexible. So it's a trade-off between flexibility and potentially some protection, but that's something that we're going to look at, and then look at ways that we might include some flexibility with that, so to speak. Here's, I think for me, one of the big things with this, the software. Version 2 of the software is now being tested, and it's a pretty big change from what that original version was. With this version of the software, you can select the number of rigs and the number of antennas you want without going in and changing the actual code itself. It's a variable that you will just modify. And then from the total number of rigs, it'll automatically calculate the number of antennas that you can connect to that. It allows you the option to close a browser and then reconnect. If you remember before, I took a lot of grief on if you closed a browser and reconnected, you essentially reset the switch. This is now an option that you can enable or disable, and you do that at compile time. It did fix some things in the version 1 software that I didn't realize that there were some issues, had primarily to do with memory and the way that the Arduino handles, actually, most of these micro platforms, the way that they handle string processing is a little interesting, but it can cause memory fragmentation issues, and some people who had built the switch encountered that. Some people didn't, and what I finally determined it was on how active you were in actually switching. If you did quite a bit, eventually it would lead to that memory fragmentation. This release does fix that, and it fixed a couple of things that were related to TCP that were annoying. It was the way that they designed it, but it was certainly annoying. So that's the version that's in beta testing. Version 2.1, which is in, actually I have 2.1 and 2.2. 2.1 allows your call sign as a variable, so that you just specify your call sign in the area where you're defining the rigs. And I'll show you that in just a minute. This is a snapshot of it. I think the next one's a little better that I'll show. And then you can use, it will display your call sign on the web page that comes up on the browser, as well as on the LCD. That's an option. If you don't want that, then it could optionally, it could display on the LCD the IP address. If you do nothing, then you continue to feed MyEgo, because it will say NU0V ham switch. As big as my ego can be sometimes, you know, you're feeding my ego. But those are things that you can optionally determine and set up just prior to compile. And this is a snapshot of that area. We define these variables and these options. If you define those, then that's the code that gets included, and I'll explain that in just a minute. But instead of having to, if you wanted to change the number of radios or number of antennas, instead of actually going into the code, into the switch statements, and really doing some heavy duty lifting when it comes to modifying the code, you just change the total rigs variable. And from that, if you choose 1, then I know you want 5 antennas, etc. But we'll take a look at some of those variables. You have to tell me the network stuff that is important. So I need to know your SSID. That doesn't change. You had to do that before. Need your network password. That doesn't change. In order to connect, we need to know who the network is and what's the password. And then in this area below, down in here, this is where you specify the description of your radio. Now, if you're not using all 5, you just change the ones that you're using and just use the other ones, leave them as they are, because it won't use them. Later on, you may come back and reconfigure it and do it however that you want. But this code or these statements are at the beginning. You modify just in this area, and then it generates everything else for you during that compile process. The define, the debug variable allows you to see messages in the serial output, which could help with debugging. If you comment this out, you won't see those messages. Multcess or multicess, I've changed that. It's a different name in version 2.1. But that variable is the one that allows you to close a browser and then come back in. If you comment this out, it goes processes as it did before, in that it would, everything would go grounded. And the default restore status, that allows you to maintain the current operational status without resetting back to ground if the switch, the web server detects an error in the command. So all are those are optional. You either enable them or disable them, depending on what your choices are, is the code that gets generated then for the compile process. The big thing though is the total rigs. That allows for a lot of flexibility. And what I found out, a lot of people don't like, getting into the code. And this was something that we did in order to make it a little more flexible and a little easier. To give you a little background, the way that the compile process works, and this process is not specific to the Arduino IDE. This is the same process that compilers used back in my mainframe days. Essentially, the workflow is that it'll go through some type of syntax check. It'll go through a preprocessor. The preprocessor goes through, and there are directives that we can give to the preprocessor, and it will follow those directives. My screen just went blank. Did your all screen just go blank?
I didn't know. We saw the screen fine.
Okay. Now, fortunately, I still have what I'm doing over here. Oh, I know it. I bet I.
Got the preprocessor directives on the screen at the moment. So.
Yeah, I probably kicked the power cord. Okay, so these are the preprocessor. Now let me go back to the and finish this. So what generally happens in a compile process, that you have the source code that you've coded or that you've downloaded from somewhere, and you start the compilation. On the Arduino IDE, it's verify compile. The preprocessor goes through, it pulls in, header files that you have done a # include. That include is a preprocessor directive that tells it to go out and get that. There are other directives in cases where we had defined some type of label to mean something. For the value of 5, we have define that as the word 5. It'll go through and then replace all the occurrences of that with what the actual meaning is. So that's what the preprocessor does. Out of the preprocessor comes the extended source code, and that's what goes into the compiler. The compiler will go through, it will generate, go through and generate its output. That output is an assembly file. That assembly file is then fed into the assembler. This is all part of that compilation process. Out of the assembler comes the object code, which is almost the executable code. It's the nearest to the machine code that we have. It goes through a linkage type of process, which then pulls in or connects all external type of references or other types of calls or functions that we may have called then that were not written in our program. And then it generates that executable, which then we load up to the Arduino. These are examples of the directives, and these are actually pulled from the code that I did. So in this case, if total rigs equal 1, then it would include these definitions for the ports. They would define rig switch 1 as on port 1, which would be pin 13, et cetera, et cetera. Else if it's that, if you notice that in order to do this, I had to go to if, else if. But this is during that preprocessor. It's not during the code that's generated. That's what actually execute. Preprocessor directives only take place or are only evaluated and interpreted and acted upon during that preprocessor stage of the compilation process. But they're prefixed with a $. They're pretty limited in what they can do. They only do base things, but it actually worked out pretty well for what I was trying to do. And this is a more exhaustive list. The define If you define a variable, then you can check to see if it's defined. And we use that, we being, I use that. So if I have defined the debug variable, then it would include this code that I send to the serial monitor, and I use that for some debugging type of information. You can use an if statement. There's an example of that if directive. So if total rigs greater than or equal to 3, then it would include this code. If that test or that condition is false, it would not include the code. So it's not anything that it does from an execution phase. What it's doing, if it's true, then I include the underlying code until I encounter that end if. Some of the other things, a warning. So during the compilation process, I issue warnings. I check certain things on total rigs. I can stop the compilation process with throwing an error type condition. So even though it's limited, it made it kind of interesting, some of the things I could do during the compile process, which then led to the final code that was more customized to the individual user. And just got a few more slides. In order to see those compiler messages, though, if you do the warnings and the error conditions, you have to enable compiler warnings, and you do that through the preferences in the IDE. And if you see where the arrow is pointing, it says, I think, compiler warnings. And if you set it to default, then you should see everything that that I would be generating. If you're interested in actually seeing the code that ends up being generated once you get past that pre-processor phase, you can find it. It's stored in a hidden folder, which you can actually get to it under the users directory, in the app data folder, the local, and under Arduino 15. There is a preferences file. If you modify that, one of the parameters is the preprocessor save build files. If you change that to true and save it, then it will actually keep the build files that it generated, that it then fed into the compiler. Now this variable, it is not persistent. The change is not persistent, so you close the IDE, you restart it later, that's set to false again. So bear that in mind. But if you ever want to do that, set that to true, and then you would, and again, back in the app data folder, in their temp folder, you will find a build folder, and there's a unique build folder for each one of your compiles. And within that is a preprocessor folder. So we're actually drilling down quite a bit. And then within that, you'll see the C++ code that was generated by the preprocessor that was then actually fed into the compiler. Now, that totrigs variable, pretty important to this entire process. This just illustrates that when you specify the variable, if it's 1, then J2 becomes rig 1, and then J3 through J9 are your antenna ports. If you specify rig or totrigs of 2, J2 and 3 are for the rigs, 4, 5, 7, and 9 are for the antennas, and then so on and so forth. And what then it generates is that this is what you would see. Obviously, I didn't customize this. So for total rigs of 1, then that web page would look like this. You would have 1 radio, and then you would have 5 antennas. For total rigs of 2, you would have 2 rigs generated, 4 antennas defined. Total rigs of 3, 3 and 3, and this was version 1. This is the way that it came. So with version 1 software, you got 3 antennas and 3 radios. Total rigs of 4, you see 4 and then 2. Total rigs of 5, 5, and then 1. So that's what all of this madness kind of led then to the QST article. The QST article itself was written in the spring of 2020 during the pandemic. I actually, during that time, I was pretty ill, and I had a couple of things that simultaneously occurred, and I was bedridden for a couple of weeks. I was very lucky that at that point we had gone all remote from teaching, so I literally taught from bed. The kids didn't have a clue that there was really anything that was wrong, and it was during this time that that I wrote the article, because you can only stream so much Netflix, you can only read so many articles, you can only do so many things, and so I, just as something to keep busy, I wrote the article. And this article was actually the first one that was written. The checker article was written after that, yet the checker was published first. The sole purpose or the motivation for me in writing that article was to encourage others to try this, to fabricate their own boards from existing designs, or if you have your own design, fabricate a board. It's not all that expensive to do that, and it can really open up a lot of avenues for you. There was quite a bit of errata for the article, and a lot of this was based off of the final proof that they sent. I don't think they got all the changes to that, so I should send you the errata, Nick, so that you have all that, and so that it can change. So they'll have the changes that they need for the article. If you remember, I opened up this presentation with, I had a quest, and I was on a quest to make a change because I didn't want to walk out in the cold, essentially, or the rain, to manually switch configuration of that vertical antenna, that QRP guy's vertical. I still haven't done that. The web switch became a labor of love pretty much over the last few years, and we're still working on it. We do have, again, people that have built it. Version 2 of the software is in beta testing, and from all accounts, everything is going quite well with that. My one user who was yelling the loudest, but in a constructive way, you know what I mean? They're the ones experiencing the most problems. They're the one, he's the one that's actually the happiest. So I'm pretty comfortable with the code, and we'll probably be releasing that within in the next few weeks or so. Just some of the other stuff going on, really the polarity checker, for those of you who weren't here for that talk. Very simple circuit that I kept hooking up these barrel, my cables, the plug, I would always reverse them and getting into trouble. And so that was the need that drove during the checker. The original one had 2 resistors on it. The second version of that had 1 resistor because you didn't really need to do it. I do have a power pole version of that. Eventually a power pole cable has to connect to a power supply. And if one doesn't have that power pole connector on it, then you could still have the situation. So I have a version of that out there as well. I just showing you the board. I have no idea why I had that animation. Obviously, I didn't mean to do that. So the key insights I hope that you got from today, experiment, keep on experimenting. Experimenting is one of the great things about our hobby. It's how we improve things, and it's how we come up with cool stuff. Design your boards, document your designs, share those designs, right for your local club, right for your national organization, and share that information. That's what really led to this labor of love that I call the web switch. Thank you all very much. I hope that you got something meaningful out of this presentation. We did walk through the whole journey this has been over about a 3-year period of when we first started this project. If you have any questions, you can certainly reach out to me. There's my contact information, NU0V at ARRL.net. Are there any questions with the remaining time that we have that I could answer for you? And I'll go ahead and stop the share.
Okay, brilliant. Thank you very much, John. And you answered the question yourself. I was going to ask you how much your life had been improved by the fact you could now select the antenna on your vertical, and you haven't quite got there yet. So I think a number of us smiled ruefully at that point, realizing at some stage we've all gone in and spent hours and hours on major changes and had great fun doing it, but haven't actually done the thing we set ourselves as the target in the first place. So a 10 out of 10 for your honesty there, John. Who's got a question for John, first of all? Yeah, go on, Roger.
Hi, John. Thanks for that. Really interesting. I wondered. I must have missed it. How did you find the web server when you plug it in your network? How do you know what IP address has been assigned? Do you just have to search for it manually, or how do you do it?
You can actually. There is a call that you can make to retrieve the IP address, and let me. If you can bear with me for a moment, I can actually bring up the code and show you. I don't have the fastest PC in the world. And let me go ahead and actually, let me go ahead and share the screen again. And we will go with screen 1. Okay, can everyone see the code?
Yep.
Okay, may take me a moment to find it, but that's actually something that we can retrieve through a standardized call. And it should be pretty close down here. Okay, here's where we're doing the connecting. Okay. So in this case, it's a Wi-Fi.local IP is the function, and then it will return your IP address. And that's what I do when I print it onto the LCD.
All right, so you've actually got to go look at the device to see what IP address has been assigned that day, or when you first plug it in.
Yeah, and the LCD will display that.
Yeah.
So
yeah, if you plug it in somewhere else remote, you've got to be able to see it first.
yes.
Right.
Yeah.
Got you.
And so that's why the LCD was so important. So that we could display that.
I just wondered that I must have missed that. I thought you were going to sort of search for it on the internet, or on your own local network, rather than physically go look at the device.
Yeah, well, neither one of us are probably that psychic. So yeah, we had to return that through that. Otherwise, we could probably poke around in some of the memory, but fortunately, through the library with the ESP8266, this is just one of the functions where you can just access it, through that.
Yeah. No, thank you. Thanks very much.
You're welcome.
Yeah, thank you, Roger. John, before anyone else comes in, I had a quick question on that Huzzer chip, the ESP 8266. So you can connect it to your PC with a standard FTDI cable.
Yes.
But what do you then use? What do you have to download a bootloader? What do you do to actually get the program onto the chip itself?
No, the board itself, you push, there are 2 buttons. You push one down first, you push the second down, release it, and then it goes into bootloader mode.
Oh, okay.
And so it's really simple to program.
Right. So there's a reset button and then there's something else button, and you
right. I don't remember their terminology. I'd have to go look at it.
Yeah. Okay. Yeah, because you started off by saying, try and do this without having to compile the code, and you showed us how you could do that. But I was just wondering how physically how you did do it. So.
Oh, right. Because I
started
similar
off
to the
with
Arduino,
software. So you've got the kind of bootloaders built into it.
Right.
So
Yes, it is.
comes up. Yeah. Okay. Thank you. Right. Anyone else got a question to John?
John, what was the turnaround time and the cost for making those boards?
It really depends on the shipping. Normally, the fabrication time was just a couple of days. And I do a lot of the fabrication in China. And so if I took the boat, it would be, several weeks. If I had it flown DHL, I could have the board within a week. Boards.
What do they charge for each run?
You can usually get about 5 boards for $2 or something like that. For larger orders, the last order I did, I think I paid about $30 for the boards, and I think I did about 20 boards, and it was as much to ship them as it was to, fabricate them, because I had DHL. I had them flown over.
Was there a non-recurring charge for
it? As far as, I guess I'm not quite sure.
Just for that batch of boards, did they charge you $200 for the engineering part of it, or?
Oh, no. There was the engineering. If they have to do a lot, their engineering fee. The only time I've had that was on the checker boards, because I had multiple boards fabricated on one physical board. It was like $3.
Oh, okay.
It wasn't.
What company did that?
It was JLC PCB.
JLC?
I think it's JLC. Or hold on just a second. I can tell you. I've got them right here. It's either JLC or JCL. It's JLC PCB, and they're out of China.
Okay. Thank you.
And I've been pretty happy with the work.
Good.
Okay, yeah, good question, Steve. Thank you, John. Anyone else with a question to John?
Yeah, I apologize for my wife coming through here. In her defense, I was supposed to get something out for her, and of course I forgot. That was my own fault. And hopefully entertaining.
We've all been there, John. Yes, Terry.
Yeah, hello, John, and blimmin' heck, how did you get all of that in without repetition and deviation and? You mentioned Wireshark, and several years ago now, I wanted to see what was on the network, and I downloaded Wireshark, and I looked at various fora, and I was scared out of my life that if I was even to breathe on the escape key, the world will come to an end. Consequently, it sits on the MacBook, and never used it. Is my worry about Wireshark rather unfounded? Is there a basic switch it on and count 5 before you do anything? Is there some primer that I could dive into?
There are some books out there on Wireshark. There are a lot of books that have information about Wireshark. Remember that Wireshark is a packet capturing tool.
Yeah.
So it does nothing to the network. The only thing that it does is that for any packet that hits your network card, it just saves a copy. So the only real impact is the amount of storage that you'll be using on the device where you're doing that packet capture. So it's not going to do anything to that network traffic. It's just going to keep a copy that you can go back later and take a look at it. The one thing that I should point out is that if you are using Wireshark on a wired network, in other words, if your PC is using an Ethernet cable and it's plugged into, if you're plugged into a switch, you won't see all of the traffic, because a switch will only forward traffic that would be destined for your specific device. Whereas in a Wi-Fi environment, it's hard to do that because it's a radio signal. So you get to capture everything because everything is broadcast, over Wi-Fi. Whereas in using a switched environment, the only thing coming down the cable is specifically addressed to you.
Okay, and is there a way of limiting the file size that is generated? In other words, so I can say show me everything for 10 seconds rolling on, yeah?
You can do a couple of different things. You can use display filters. So if you stop the capture after 30 seconds, you can use a display filter to limit what is displayed. However, you still would have captured that entire 30 seconds. Another technique that you can use is that you can set up what's called a capture filter. And a capture filter will only capture traffic that meets certain conditions. And the way I use it most commonly is that I will only capture packets from or to a specific IP address. So it really narrows the field for what you're actually going to capture, and it significantly reduces the file size of the capture.
Thank you. That puts my mind at rest, rather. Thank you.
Okay. Oh, you're welcome.
Yeah, thank you, Terry. Anyone else with a question to John? Yeah, Jeff.
Yeah, good evening, John. Thank
Good
you very
evening.
much. Very interesting. I have two questions, actually. The first one is, can I use this device remotely if I have a cottage 20 kilometers away from here, which is not true, but could I use that over the internet or telephone line or a mesh network? And the second question is, you say that your antenna 2 is a fractal wing loop. What is that? What is a fractal wing loop?
Oh, fractal wing loop. Okay.
Yeah, what is your experience with that?
It's probably the folly of my youth, but at the time I created that antenna, I was reading a lot about fractals, and there's one individual, he's out of one land, and I can't remember the gentleman's name. It seems like it's Cohen or something, where he was experimenting with using fractal patterns as the basis for antenna design, and that intrigued me. And so I created an antenna that it was a loop, and then I added perpendicular to the plane of the loop these fractal designs that were both were equal, and just to see what it would do to it. And it was a 15-meter loop, and what it actually did is that it made it resonant on 20 meters, which. And I spoke with Jim Duffy, and Jim Duffy is a physicist. He's a very well-known QRPer, and he told me that probably the design is a combination of capacitance and inductance, just based off of the design, which is causing the effect, rather than anything associated with a fractal or fractal design. But hence that's where the name came from, because it used that iterative pattern in the wings. And actually, I worked DXCC on that antenna, so it actually worked pretty well. It's in the attic over my garage, so it worked quite well on 20.
Okay.
But
And
that's
the
what it
remote,
was.
yeah. And the remote question.
The remote question is theoretically yes. I've never tested that.
Okay.
Remember that the IP address that you'll get over your network, whether you hard code it or whether DHCP serves it, is more of an internal address. It's non-routable on the internet. Addresses with a 192.168 whatever, 172.10, a 10 dot, those are non-routable, so they won't work on the internet. However, most of the home routers that we have, have the capability of utilizing NAT and port forwarding. So theoretically, yes. And in fact, what's driven a lot of the demand for the people who have gotten some of the boards from me, and when I say that, I've had just a very limited set, because I hadn't planned on really doing anything with that. But that's primarily their interest, is that putting that in operating remotely. But it should work. Your home router should have capability for NAT and port forwarding, and you should be able to do that.
Okay, thank you. Interesting. Thank you.
You're welcome. But I've never tried it.
Okay.
Okay, thank you, Jeff. That's a good question. Anyone else with a question to John? No, if not, can we show appreciation to John tonight in the usual way? Thank you, John, for very, very interesting talk tonight, and for the time putting it together. Thank you, John.
thank you all very much. I really appreciate the opportunity to come and speak with you.
That's excellent, and we'll send you a link to the recording of it, which we'll put onto our YouTube channel as well, John. You're welcome, obviously, to do what you want to do with it.
Okay.
Just gonna.
I'll make sure my wife gets to see the portion that's relevant for her.
Trying to get
Yeah,
some. Good points.
thank you very much, John. Cheers.